Azure Databricks is the jointly developed data and AI service from Databricks and Microsoft for data engineering, data science, analytics, and machine learning. The Azure Databricks Lakehouse platform gives you the best of data lakes and data warehouses on a simple, open, and collaborative platform that securely integrates with your existing Azure services. In this demo, we'll be working with power output and maintenance system records from a fleet management system used to maintain wind turbines across the United States. Orchestrating data pipelines for ETL operations is easier than ever thanks to the integration between Azure Databricks and Azure Data Factory. We've created an Azure Data Factory pipeline that uses copy commands to incrementally ingest data from the fleet management system in SQL Server to our landing zone in Azure Data Lake Storage Gen 2. Data Factory then executes a Databricks notebook to process the data using Databricks Autoloader and saves it into Delta Lake tables. You create the Azure Data Factory to Azure Databricks integration by adding an Azure Databricks notebook activity to the pipeline. When I run the pipeline, the output window shows the different activities that have been run, and in my Databricks activity, I can actually browse to the notebook that was executed when the pipeline ran. We can see from the metadata this notebook executed successfully, and it took 23 seconds. The real work in the code initiates when I create a data frame called maintenance header df that reads the Parquet file that ADF drops to the landing zone. Even though I am reading Parquet data, my format is cloud files because I'm using Autoloader to automatically detect new files as they land in my landing zone. I also create a data frame for my power output data. I write my data frame to my Delta Lake tables using the WriteStream command, specifying the format as Delta and providing the table write location in Azure Data Lake Storage. I'm also using an option called Trigger Once to program my code as a streaming pipeline but run it as a batch-oriented execution. Next, we're using an IoT simulator provided by Azure to send live streaming data payloads similar to those created by real wind turbines into Azure IoT Event Hubs. Once we press the Run button, the simulator starts sending telemetry and weather data to the IoT Hub every second. Within Event Hub's metrics, we can see that the simulator is running and sending new messages to Event Hubs as we speak. In Azure Databricks, we created a notebook that reads the streaming data from the IoT Event Hub in real time. The first part of the code parses raw JSON data from the IoT devices into data frame columns. As you can see, the connection is really simple using the Spark connector to Event Hubs. We then split the weather data and turbine data into different data frames and store the data in Delta format. Delta format is the foundation of the Delta Lakehouse architecture, and it provides streaming transactions and incremental data loads on top of your data lake. In this visualization of the streaming data frame, you can see the data being refreshed live, with new data points arriving every second. In the third part of the demo, we are enhancing data by combining information from the maintenance system, loaded by batch processing, with IoT and telemetry data, loaded by streaming. Then we're storing the result in a Delta Lake Gold table on Azure Data Lake Storage, and also publishing it to Azure Synapse Analytics dedicated SQL pool. The version loaded into a Synapse dedicated SQL pool is typically a smaller table with higher level aggregation used for high concurrency, low latency workloads. Azure Databricks provides a high-performance connector to Synapse SQL Pool. This connector supports both batch and streaming refreshes. In this case, the Turbine Gold table is being continuously refreshed in streaming updates. The Delta Lake Gold table will be used for data science and machine learning, as well as data exploration and data analytics performed directly in Databricks notebooks and Databricks SQL Analytics. As a business analyst, I can see what data is available to me in SQL Analytics. I create a new query by clicking the New Query button in the UI. In the data browser, I can connect my IoT demo database and see the tables available to me and their metadata. I can then query my Turbine Gold table, browse the data, and even make simple data visualizations. But if I really need to make my data shine, Azure Databricks integrates with Power BI through an optimized connector that provides a secure, more interactive data visualization experience for data stored in your data lake. To connect Power BI to Databricks SQL Analytics, I browse to endpoints and review the connection information of my endpoint on the Connection Details tab. From within Power BI, I click on Get Data, More, Azure, Azure Databricks, and then Connect. I copy the server host name and HTTP path information from my endpoint and put it into Power BI. Optionally, I can enter my database name, select Import or Direct Query, and then click OK. When the table and view list comes up in the Navigator UI, I can select the Turbine Gold table and click Load. Once Power BI has loaded my data into the data model, I can begin dragging and dropping the field list onto my canvas to dissect the data interactively, or even create visually appealing, enterprise-ready reports and dashboards that can be published to the Power BI service and shared with my teams. Download the notebooks used in this demo on the Databricks Demo Hub by clicking the link in the description below. Or visit databricks.com/try to get started with a free trial of Databricks today.